Hello, this is Mr. Bess. Welcome to Chapter 1, Homework Questions 13 through 17. Question 13. Consider the situation described below. Meredith lives 24 blocks from her friend's house. If she travels 1 block every minute, how many minutes will it take her to reach her friend's house? What if she travels 2 blocks every minute? Show how you calculate each answer. Once again, there's multiple ways to look at this, but one way is if she is traveling 1 block every minute, then you can take 24 blocks and divide that by 1 block every minute, and that will give you 24 minutes. So that's how long it'll take for Meredith to get to her friend's house. And then continuing on, if she travels 2 blocks every minute, then you can say, all right, well, I'm going to take 24 total blocks that need to be traveled. And now we're going to divide by 2 blocks every minute. So now she's going to get 2 blocks for every minute, so that would give you a total of 12 minutes it would take to travel to her friend's house. And once again, that's one way to look at it. There's visualizations that you can use, lots of different ways, but no matter what, you need to show how you calculate your answer. So no matter which way you do it, you got to show how you're doing that. All right, on B, copy and complete the table below to represent the amount of time it would take Meredith to get to her friend's house if she traveled at different rates. So right now, the speed in blocks per minute and the time to get to her friend's house in minutes. So we know if she is traveling 1 block per minute, it's going to take 24 minutes to get there. If 2 blocks a minute, then it's going to take 12 minutes. And then what happens if she travels 3 blocks? Well, 24 divided by 3 would be 8 minutes. And then you can kind of keep going. So each of these, I'm taking 24 total blocks divided by 1, 24 divided by 2, 24 divided by 3, and so on. 24 divided by 4 would be 6 minutes. 24 divided by 6 is 4 minutes. 24 divided by 8 would be 3 minutes to get to her house. 24 divided by 10 would be 2.4 minutes. 24 divided by 12 is 2 minutes. And then if she's traveling 24 blocks per minute, it's only going to take her 1 minute to get to her friend's house. And so we completed the table. So we're good there. Part C, what happens what happens to the time it takes to get to her friend's house as Meredith's speed increases? Well, if you're increasing your speed, it's going to take you less time to get to her friend's house. So what's going to happen to the time? The time is going to decrease. Now the second part of this is to explain that. So make sure, I'm not going to write it down, but make sure you explain why that is happening. So as once again, Meredith's speed increases, why is it that the time decreases? Question 14. Evaluate each expression if r equals -3, s equals 4, and t equals 7. So it's given us 3 different variables that we need to plug in. Not all of them are being used on every single problem, but you need to plug them in. And once again, you're only replacing the variable in each of these expressions. So the first one is r is being squared. Well, if r is -3, then we need to include -3 in parentheses because we are squaring that r value, which includes the negative. So plus the square root of s, which is 4. Now we evaluate it. -3 times -3 is 9. The square root of 4 is 2. So this is equal to 11. B, we have t minus r, so that's 7 minus, and once again, minus r. R is a -3, so I'm going to put that in parentheses, t minus r, which is 7 minus -3 divided by s, and that's a 4. So what do we get? 7 minus negative 3 is 10 divided by 4. You can reduce the fraction to 5/2. You could also write it as 2.5, 2 1/2, a couple different ways. Just make sure it is reduced or simplified. C, we have 2 times s squared. So you could either use parentheses or I just put the dot times 4 squared plus r. So I'm going to put that in parentheses to distinguish that that's plus negative 3 minus t, which is 7. So order of operations, we first square this 4, which is 16. Instead of plus negative 3, I'm just going to change it to minus 3. It's the same thing. 2 times 16 is 32. And now we work from left to right. 32 minus 3 is 29. 29 minus 7 is 22. And then the last one, D, we have 3 times the quantity, which would be s minus t, so that's 4 minus 7, and then that whole thing is squared. Order of operations, we have to do what's inside the parentheses. So 4 minus 7 is negative 3. Then we have to square negative 3, so that's negative 3 times negative 3 is 9. Then we can take 3 times 9, which is 27. Question 15. Finding and using a pattern is an important problem-solving skill you will use in algebra. The patterns in diamond problems will be used later in the course to solve other types of algebraic problems. Look for a pattern in the first 3 diamonds below. For the 4th diamond, explain how you could find the missing numbers if you know the 2 numbers. So right now you're looking at the 4 diamond problems below. They're all complete except the last one. So what we're trying to identify is how are these numbers being formed? And you're trying to come up with a conjecture, and then we're going to see if it works for all of the 3 that are completed. So what I notice here, a couple different things, but you have these 2 numbers, the 5 and the 2. I realize that they add to give you 7. And then if you multiply them, they multiply to give you 10. Now the question is, does this work for the other 2? So once again, 2 and 3, do they add to give you 5? Yes. And do they multiply to give you 6? Yes. Let's try the last one. Negative 1 times negative 4. Well, let's add first. Negative 1 plus negative 4 is negative 5. And then negative 1 times negative 4 is 4. So it looks like all of them check out. So what do we know, or at least what we think here, is that this number times this number gives you the top part, and then if you add the 2, it'll give you the bottom number. So explain how you could find the missing numbers. And so I talked about it, but you need to write it down in terms of what we just discovered. Now, the rest of them we're gonna complete. We're gonna copy the diamond problems onto your paper and then use the pattern you discovered to complete each one. So the 2 and the 5 is similar to what we saw in the very first one. Is 2 plus 5 is 7, and 2 times 5 is 10. Negative 2 plus negative 1 is negative 3. Negative 2 times negative 1 is 2. On the next one, we're now missing the 2 numbers. So now we got to think about this. What 2 numbers, I'm going to call this one X and this one Y, what 2 numbers add to give you 6 but multiply to give you 8? So it's easier to look at the multiplication because you only have so many options for the multiplication. You have 2 and 4 and 1 and 8. So 2 times 4 is 8 and 1 times 8 is 8. But when you add those, which one gives you 6? Well, that would be the 2 and the 4. 2 plus 4 gives you 6. So here are your 2 values that work for this problem. And it doesn't matter where you put the 2 and the 4, because either way, 2 plus 4 or 4 plus 2 is 6, and 2 times 4 and 4 times 2 is 8. They're commutative. It doesn't matter the order that you multiply them in. D's a little different. D gives you the top part and one of the numbers, but not the other one. So we'll call this number X, And then this one we'll just call A. So the question now is, what number times a half is going to give you 4? And then what number plus a half is going to give you A? Well, if you look at my two equations, the first one only has one variable, the second one has two. So we're not able to solve this one because we have two variables. But the top one we can. What number times a half gives you 4? If you're thinking 2 times a half is 1. We want the number to be bigger than 4. So 8 times a half, if you take half of 8, that is 4. So if we put an 8 here, now 8 times 1/2 is 4. So it works for the top. Now the question is, now that we know this is 8, we can replace the x that we now found out to be 8. What is 8 plus a half? And then that's what we can fill into the bottom. So 8 plus a half is 8.5 or 8.5. And the last one on C, similar to C. So we know that we need two numbers that add to give us -7, but multiply to give you 12. So x plus y has to equal -7, but x times y has to equal 12. So with multiplication of 12, we got a couple options. We have 1 times 12, we have 2 times 6, and 3 times 4. So none of those are going to add up to a negative, but remember, also, if we take -1 times -12, that gives you a positive 12, -2 times -6, and -3 times -4. So they still give you a positive 12, but now when you add them up, you will get a negative. So what set there, when you add, give you -7, and that would be the -3 and the -4. Once again, the order of those two numbers don't matter because addition and multiplication is commutative. So that is how you will work through the diamond problems, and you'll see these throughout the entire textbook, and we'll start to use them later on for something more specific. Question 16. What value or values of x will make each equation below true? So it looks like we are just going to solve some equations. And I'm going to solve these algebraically. Some of these you can do in your head, but if we subtract 5 from both sides, x is equal to 0. So that's the value of x that would make it true. On B, we have 2x minus 6 is equal to 3x plus 1 minus x minus 7. So on this one, a little bit more complex. Rewrite that 3 there. It looks like we need to simplify the right-hand side because the left-hand side is already simplified. We can't combine any of those values. And so on the right-hand side, we have an x term, 2 x terms, and then we also have a constant that we can add as well. So we'll combine those, and we get 3x minus 1x, that's 2x. 1 minus 7 is minus 6. And then now when you go to solve by getting the variables on the same side, subtracting 2x, we get -6 equals -6. Now the value of x is gone. So what does this mean? Is -6 equal to -6? Yes, that's absolutely a true statement. So what that means is that no matter what value for x that you plug in, it's always going to cancel out like you saw there, and you're always going to be left with a true statement. So that means that x can actually equal any number. So you can plug in positives, negatives, fractions, decimals, rational, irrational. So x can be any number or any real number. C, 3x plus 1 equals 43. So we can subtract 1 to get the constant on the opposite side of the variable. Since it's 3 times x, we're going to divide by 3. And 42 divided by 3 is 14. And the last one, D. 4x minus 1 equals 4x plus 7. You're going to notice this is similar to B. Don't have really any simplifying or combining of like terms. You can just add or subtract your variable term to both sides, and the variables cancel out again. But what you'll notice is on this one, -1 is equal to 7 is not a true statement. So when you plug in any value for x, you're always going to get a statement that is false, which means there are no values of x that will work. So we're going to say that there is no solution to this problem. There's no values of x that will make this statement true. Question 17, last one. Simplify each expression. So we're dealing with fractions here. Some of this stuff can be done on your calculator. I'm going to go ahead and just show you how to do it without the calculator. So on part A, you're adding fractions, which means we need to find a common denominator. So we have to look at the 9 and the 2, and we need them to be the same. Well, what do those numbers both go into? The smallest one would be 18. So we can rewrite the fraction 2/9 by multiplying by a form of 1. 2 over 2 is 1. But when we do 2 to the numerator, that's 4, and 2 to the denominator, that's 18. So 2/9 and 4/18 are exactly the same equivalent fraction, just different denominators. And we'll do the same thing with the second one, but this one has to be multiplied by the form of 9 over 9. So that would give you negative 9 over 18. And then you add your numerator, so that would be 4 plus negative 9 is negative 5 over 18. You keep your denominator the same. And you can just leave it as a fraction. Part B, just make sure it's reduced. Part B, same idea, except we are subtracting instead of adding, but we still need the common denominator. So this one we're looking at 7 and 5. Sometimes you can just multiply the two together and get 35. That works. It's not always the smallest one. In this first two cases it is. So we'll change the denominator to 35, which means this needs to be multiplied by 5 over 5, and this one is 7 over 7. So we get negative 30 over 35 and 21 over 35. So what is negative 30 minus 21? That's negative 51 over 35. It is an improper fraction, but that's perfectly fine, but it is reduced. So we're going to leave it as negative 51 over 35. Part C. Now this is multiplication. So multiplication and addition and subtraction are different in terms of how you complete these. We don't need a common denominator. So we're just going to cancel if we need to, or multiply straight across. Now some of you will just want to multiply straight across and get negative 18 over 30. And there's nothing wrong with that. The only thing is you need to reduce that. So each of these numbers can be divided by some common factor. In this case it can be divided by 6. And that would give you negative 3 over 5. And that would be the reduced form. And that's perfect. Another way to look at this problem is to cancel any common factors before you actually multiply. So for example, 2 divided by 10 is, 2 goes into 2, 1, and 2 goes into 10, 5. So that fraction, 2/10, reduces to 1/5. Now don't forget the negative. And then 9 over 3, same idea. What goes into 3 and 9? 3 does. And so you reduce all those by a factor of 3. Now when you multiply across the numerator and denominator, you are already simplified. So either way is perfectly fine. D is division. Now when you divide 1/4 divided by 2/7, there is a rule that if you multiply by the reciprocal, that's how you change it basically back to multiplication. We'll talk about why that actually works. And so now when you do this, now you can just multiply straight across and get 7/8, and that will be your final answer. Now one way to explain why this actually works, if you take 1/4 and write it this way in terms of your division, 1/4 divided by 2/7. So the reason you multiply by the reciprocal, because this is your kind of big fraction bar right here, if I multiply this denominator by 7/2, that will cancel the denominator. And if I multiply the top by 7/2, because remember, you have to multiply by a form of 1. So 7/2 divided by 7/2 is 1, and as long as you're doing it to the numerator and to the denominator, then you're mathematically okay. And so what happens is, with the bottom here, we have 2/7 times 7/2. Well, that's just 14 over 14, which is equal to 1. So now you have this big fraction over 1. Well, that's 1/4 times 7/2. And that's where you get the 7/8 over 1 divided by 1 is still 7/8. So that's why that rule of multiplying by the reciprocal, at least one way to explain why that actually works and why it occurs.